Hey, what's up guys, welcome to my YouTube channel. In this tutorial, I'm discussing about how to create machine learning models to make prediction on our test data of our Titanic dataset. We're going to go over different classification algorithms such as your logistic regression, decision trees, random forest, and many more. Guys, before going further, don't forget to like, subscribe, and turn on the notification bell so you'll be the first to be notified when I upload new coding videos. Okay, guys, without further ado, let's go. With the first step in this our modeling tutorial, we are going to be importing our required models. Okay, importing required models. Okay, first thing we're going to be importing, okay, from sklearn.processing. I'm going to be importing scalar from. We're also going to import from sklearn dot model selection. Also going to import train test split. Okay, train test split. Well guys, this is a continuation. This video is a continuation from the video which we created earlier, which is the processing video. We processed our Titanic train data set. This is what we did in our last video. In this video, we are only going to be dealing on the modeling, where we create model to make prediction on our test data. Okay, so what we're going to do next now, we're going to be splitting our data set. Since we have just a train and a test data, and our test data don't have the survive column, which are use our dependent column or our target column. So we're going to be splitting train data into subtrain and sub test. Okay, we want this now. Okay, we're going to split train data into subtrain and sub test. Okay, to do this, first of all, I have to define my x, which is my independent variables. It's going to be my df survived, df dot drop, I'm going to drop this my survive, which is my dependent variable. I'm going to drop in it. Okay, then my y, which is my dependent variable, is going to be my df survive. Okay, let me run this now. df. Okay, df is not defined. Okay, I forgot to run this, all this stuff we did in our format video. Let me just run all of them again. Okay, let me just run all of them. Again. Okay, let me run it now. Okay, it should work. Okay, then let me observe my x and my y data. When I run my x, you can see here that it contains all my columns except for my dependent column, which is my x, which is my survive. And when I run my y here, you can see it contains just one column, which is survive. Okay, so the next step now is the scaling of our data. Okay, scaling data set. Okay, to do this, I want to be using this standard scaler which we imported. The reason why we're going to be scaling our data set is to make our model fit more easier on our train data. Okay, we don't want a situation where it will take longer for our model to fit on our train data, so we're going to be scaling it. Okay, and this our standard scaler is going to make our data set to be in the range of 0 to 1. Okay, define scalar should be equal to standard scalar, then and scalar dot fit go to fitting x, and you know we only scale our independent data, which is my x. Okay, we don't scale my dependent variable, which is my y. We only scale x. Okay, and after doing this, I'm going to be transforming our. Let me run this now. Okay, I already scaled it already. Next step now, we're going to be transforming our s scaled to be equal to, okay, scalar dot, we're going to be transforming our x data, and it's okay, it's already transformed. Then now we're going to be splitting our data using our train test which we imported here into the sub train and the sub test, so we can make prediction on the sub test data. You understand? Because this our original train data which we have, which was provided by Kaggle, we can't actually find the accuracy score on that because that doesn't have a survived column. I don't know if you understand me. We can't find an accuracy score on that because it doesn't have a survived column. So we have to split our train data into a sub train and a sub test data. Okay. Same. Okay. So I'm going to call this S train X test Y train Y test should be equal to train test split. This model which we imported we automatically split our data for us depending on the percentage which we provided. Train test split accept 4 major parameters, okay, which are x, our independent variables, our y, our dependent variable, then train size. We want our train size to be 80% of our data. I want to call it 0.8, while the test size is going to be 0, is going to be 20% of our data. Okay, then want our random state to produce same result. Okay, so we don't have a random sample each time run our code. We're going to use 42. Okay, let me run this now. Let me observe my S train dot shape. So my X text shape. Okay, let me run this now. You can see here we have a shape of 11 by 712 rows, which is 11 column by 712 rows, and for our train data, but for our test data, we have a total of 179 by 11 column. Okay, so what we're going to do next now, we're going to start modeling our data set. Okay, our quiz that we're going to start modeling our data set. The first classification algorithm which we're going to be using is the logistic regression. Okay, logistic regression. Okay, it's very easy. We're going to import it from sklearn.linear model. We're going to be importing from linear model from sklearn. Linear model import logistic regression. Yeah, let me run it now. The next step, what we'll be going to is to instantialize it. Okay, to do that, we're going to call it model one. This is our first model, logistic. What is spelling? Logistic regression. Okay. After doing that, we're going to fit it now. We're not going to replace any parameter within it. Okay. Then we're not going to fit it. Our model one dot get x string. Then our y, we're going to fit into our s string data and our y string data. Okay. Everyone is all right now. Okay, you can see here what it's telling me. Okay. I don't really know. Now let's actually compare. Let's actually check the result of this our logistic regression, which we just created. Okay, which we just fitted. To do that, we're going to be using accuracy score, which is a score metric provided by sklearn from what went from sklearn dot metric. I want to import accuracy score. Okay, and look on it now. Then I'm going to be checking for the accuracy score. Accuracy score. Okay. First one I want to provide the first parameter is going to accept is our y true label, which is my y test. Actually, let's actually make predictions first before we start checking for the accuracy score. Okay. So let me actually come here and say my y predict should be equal to my model one, which is my logistic regression dot predict. I'm going to make prediction on my what? I'm going to make prediction on my x test data. Okay. When it makes this prediction, it's going to give me a result of if the individual survived or not. Being on this now. Then let me check. Let me give you a sample of my y predict. Just give you a sample of it. Yes, now you can see here. This is our prediction which our model predicted. And let me check the accuracy score. My y test and my y predict. Let me move it now. Oh, you can see here my model is having an accuracy of about 79%. Okay, my model is 79% accurate. Okay, meaning in every 10 sample, my model is able to give at least 8 good prediction, meaning the 8 prediction it gives is always correct. Okay, that's what this my accuracy score is telling me now. So we're going to be going over to the next machine learning algorithm which we're going to be using. We're going to be going over the decision tree. Decision tree. As usual, we're going to import our tree from sklearn. sklearn is a very good library. It provides us with most of our machine learning model, if not all. Okay, from sklearn dot tree, I want to import the decision tree class file. We want this now. Then I'm going to go in calling this model 2. Then I'm going to call our decision. And this spelling is really decision tree classifier. Okay. This time we're not going to be leaving this space empty. You're going to accept some parameter which we are going to provide now. First, the first parameter I'm going to accept is the splitter. This splitter is going to make we're going to setting it to random, so our model don't overfit. Okay. Then next parameter is the mass depth, the depth of the tree. Okay. We're going to be setting it to 4. Okay. So also our model don't overfit. I mean, if we have set it to maybe 6, it will keep splitting and splitting until maybe our model start overfitting. But now I'm going to set it to 4. Let me run this now. So I want to fit our model just as we did with our logistic regression. Fit s join y train. Okay, let me run this now. Okay, and let me check for my accuracy score. Right, word model to predict our S test to give us our Y word. Then I will adjust for my accuracy score. My Y2, this is my Y test, and Y word. Oh, our accuracy score have increased from 79 to 81. Meaning in this our data set, my decision tree classifier is performing better than my logistic regression. Okay. Well, let's go over to another model which I'm going to be using. I'm going to be using let's use the random forest model, machine learning model. Random forest. Okay, let's use random forest. Okay, actually it has similar principle as that of your decision tree. Okay, it's an assembling method. So to import our random forest model, we're also going to be importing from sklearn ensemble. Import random forest classifier. Let me run it now. So I'm going to call this model theory random forest classifier. Then it's going to be accepting. I'm going to be giving just 2 major parameters. Here are the end estimators. I'm going to be estimators. Okay. I'm going to be setting this to Android. Then my mass depth is depth of the tree. I'm going to place in that 4 as before. Let me run this now and let me check the accuracy. Let me fit my model theory.fit. Let's train ion Y train. Okay, then let's make prediction per model. Predict my X test. Let me run this now. Then let me check for my accuracy score. My Y test, my Y word. Let me run this. Oh, my accuracy score dropped. Okay, it's also performed quite well, but this is that performing that well compared to this my decision tree model. So I think the model which we are going to use it to make prediction on our test data on our original test data is going to be our decision tree. Okay, we are going to be going with decision tree since it's performing better than the rest classification model. Okay, now we're going to be making prediction on our actual test data set. Okay, prediction of actual. Okay, so as I said before, when you download your data set from Kaggle, you're going to have three separate data set, which is your train, your test, and your gender summation data set. Your train, which we have been using to train our model. Now we're going to make prediction on our test data. Okay, then before we now submit it, before we now we're going to arrange our column in our submission sample data set. Okay, so the first step, we're going to be reading our test data set now. df2 is equal to pd bid csv. Okay, run this, and let me check our test data set. Okay, here you can see our test data set is a continuation from our train data set. Our train data set ended in 891. Passenger ID is 892. And you can see here, this our data set don't have it doesn't have a survived colon. That's what we're going to be doing. We're going to be making prediction on that. So what we're going to be doing next now, we're going to be processing our test data. As you can see here, this name is a test colon, and our machine learning model doesn't accept data in the test format. Okay, so we're going to be processing this data set. Let's also get another general overview of this our test data. Let's call df.info. Check more information about our test data. As you can see here, okay, no, it's our df, so our training data, our df2.info. Okay, as you can see here, you can see my passenger ID, my passenger class, name of my individual, their sex, and also we are also having missing colon in our test data. Okay, as see here, we have a total of 232 rows, and also this page, there's also missing colon here, and also this cabin. So this is processing which we are going to be doing on our test data. The first process that we are going to be going over is filling in our missing colon. Okay, I guess my age colon, we're going to fill those missing colon. To do that, we're going to simply give this heading. Then again, do that as I want to speak of df.h equal to df3.h dot. I want to use this my fill now function. I want to fill in with the mean age, the mean of the colon age. Okay, let me run this now and let me check for my here. You can see all my age colon has been completed, it has been filled already. Okay, let me also fill my my fair colon. Just this have only one missing colon, one missing row. Here dot fair. Because I'm going to follow the same procedure. Okay, now dot fair dot main. Let me run this now. Let me run this. Okay, you can see here my third column has been filled. Well, when you come to this my edge column, you see that most of my AGA have all my AGA are floats, and it doesn't make sense for your age to be a floating data type. Let's convert it into an integer. For this df2.age to df2.age but type to okay, and what is now. I run this, and you can see here my age column as the it's now an integer. Okay, so what I'm going to do next now, next represent stage I'm going to go in over is a deleting of unwanted column. Okay, deleting unwanted column. Okay, going through, we're going to be deleting this carbon column because it has a lot of missing values. I mean, you can see here it have just 91 rows that contain data, the rest are none out of 418. So we're going to be deleting that for the df2 carbon. Also, we're also going to be deleting this my name column because it has a lot. When I come here and I check for my df2 dot name dot unique unique, you can see here it has, let me just use the length. You can see total length of my unique column. You can see here it has a total unique value of 218, meaning that each individual have a particular name, so it won't have any correlation with the reason why the individual survived. And also, if I were to convert this into if I were to use one hot encoding method for this my column, this my name column, I'm going to have a lot of column leading to a dimensionality course. I mean, I'm going to be having a total of 418 or to 400 and maybe 30 column. Just imagine that would take a lot of time to fit it. So I'm going to deleting it. df2 a. Also, I'm also going to delete this my ticket column because it will also check my tickets here. Last year, it also have a total of 263 unique values. So also make deleting it because it doesn't have any correlation with my dependent variable, which is survive. Let me run this now. Okay. I'm trying to okay, the next step which we're going to be going over is handling what our categorical data in our test data set. Okay, handling categorical data. The method which we're going to be using, we're going to be using the one hot encoding method. Okay, so to do this, we're going to call our data frame, which data frame 2 should be what we're going to be using pd.getDummies, which is a very easy method of one hot encoding your categorical data in your data set. Okay, get dummies. I'm going to bring that on data frame 2, which is our test data, actual test data. Then following for going to be one hot encoding is going to be my, let me run this again. So what column is sorry having categorical data? We have this my sex column and my embarked column. Okay, just those two columns, sex column back colon. Let me run this now and let me check my df2.info again. Okay, you can see here my test data is now ready to make prediction on. Okay, the last step we are going to go over is just the remaining step is to standardize my data set. Okay, to scale it. I want to also be using our standard scaler. Okay, scaling data set. Okay, then to do that, I want to name our scaled test data. Okay, s scaled test should be equal to that our scalar which we define. Okay, that our scalar which we defined earlier dot transform. We know we already defined our scalar earlier. You can see here. Where it start again. We are really gone through a lot of steps in this our modeling. You can see here when we defined it, scalar is also standard scalar. So what we are going to do now, we have already fitted it, but we're just going to transform df, so which is our test data. Let me run it now. Okay, let me show you our SQL data. Okay, when you run this, you can see here it contains values ranging from 0 to 1. You see that's just the importance of scaling your data set. It creates the range of your data set from 0 to 1. Okay, to make it easier for your model to fit it. So the next step which we're going to go over now, we're going to be making prediction on our actual test data. Okay, we're going to call this y test should be equal to a model dot. Which model I'm going to be using? We're going to be using this the model that perform better, which is our decision tree, and it's model 2. Our model 2 dot predict our s scaled test. Okay, let me run this now. So our model already predicted on our test on our actual test data. Let me check our predictions. Okay, our y tests. Okay, this is the prediction which we had. Our y test is, okay, you can see here in this place our individual didn't survive. In this case it survived, and in this case it didn't, and so on and so forth. So this prediction is what we are going to be submitting to Kaggle to get our score. Okay, so to actually make this more interesting, let's actually convert it into a data frame. I want to call this df theory. Okay, so you go to pd dot data frame, then what should be my y test. Then I want to name the column piece. So 5. Okay, this now. Let me check that from 2. Okay, you can see here this is the prediction from our decision tree model. You can see here that the predictions which are going to be submitted to Kaggle. So in our next video, I'm going to be explaining how we are going to arrange our data frame, export this so we can submit it to Kaggle and see our score. Okay, and guys, if you want to subscribe to my channel yet, don't forget to subscribe because I'll be releasing new videos on a regular basis. Okay guys, thanks for watching.